This lesson is on some measurement practice questions. And the first question we have says to find the area for this triangle to 1 decimal place. So we are trying to find the area, and before starting a question, always write down what you need. So the area of a triangle, I know the formula is area is equal to base times height divided by 2, or half base times height. Okay, so I need B for base and I need my height in order to work out the area. Now if I have a look at my triangle, I can see it's a right angle triangle, and it has a height of 17, so that's the height there, and it's perpendicular to the base, so it's got a right angle, and my base here is B. That 19, I can see it's opposite the right angle, so that is my hypotenuse, the longer side of the triangle, but I don't need the 19 centimeters. I need height and base. So height I can see is 17, but what is my base? They haven't actually given it to us. So that's where we have to brainstorm and realize we have to use Pythagoras to find the length of the base. So we'll do that first. So to find B, let's use Pythagoras. So with Pythagoras, we know the theorem is c squared equals a squared plus b squared. We know c is the hypotenuse, so in this case c is 19. So always identify your variables so you don't make a mistake. H is 17, which I'm calling my height. That can be just side A, and B can be my base. So let's substitute our values. C is 19, so 19 squared is equal to A squared, which is 17, plus B, which is my base, and I'm using B as well. Okay, now that I've substituted my values, I just have to solve this and solve for B. So you end up with B squared is equal to 19 squared minus 17 squared. This should have been a takeaway because we already have the hypotenuse. And then B squared will be equal to 361 take away 289. I'll just continue it up here. So B squared will be equal to 72. And we know to get rid of that square root, that square, we have to square root, and they cancel out. And I must square root the other side. So I'm left with B is equal to the square root of 72. This is an irrational number. When I put it into my calculator, I get 8.4852, and it goes on forever because it's irrational. And I think we'll double check with the question. Sorry, the question said to round it off to 1 decimal place. So I'll do that here. So B is equal to, now to 1 decimal place, that means I'm going to cut off everything here except for that first decimal place, which is 4. But before I do that, let's do a check. The number after 4 is 8. If it's 5 or more, we add a 1, in this case to the 4. So 4 plus 1 is 5. So we're left with 8.5 centimeters. So that is the length of my base. So B here is equal to 8.5 centimeters. So now that I have my base, I can now substitute it into my formula and find the area of this triangle. So I've got my formula here. I'll just change my color. So area is equal to base, which is now 8.5, times my height, which is 17, divided by 2. So area will be equal to 72.3 centimeters squared. Okay, our next question asks us to calculate the area of the sector below to 2 decimal places. So have a go first. Okay, so we know sectors are a portion or a part of a full circle. So if I was to draw a full circle, it's sort of like a piece of a pizza. And there's my center point there, the center of my circle. So I'm finding a fraction of my circle. In this case, a fraction of the area. And they've given us the radius. So that 18 is the radius because it reaches the center of the circle. So that's the radius. So straight away R is equal to 18. 18 centimeters. So just identify that R is 18. And so what is the formula of the area of a full circle? So the area of a circle is equal to pi R squared. Okay, so that, remember, is a full circle. So I'm going to be finding a fraction of that. And to work out the fraction of that, we know a full circle is a total of 360 degrees. And out of that 360 degrees, I am given 70 degrees. So I'm going to use that 70 to work out the fraction of the full circle. So the area will be equal to, we could also, if it helps, you can write area, just so we know what we're doing. Area of sector is equal to, so fraction of the full circle. So the formula for a sector is the angle of the sector out of 360, so that's going to give me my fraction part, of, so times pi r squared, which is a full circle. Okay, so that's my full circle, that's of, and that's a fraction. It's important to understand how these formulas work. So fraction of the full circle. And now substitute it in. My angle, the theta, is going to be 70 degrees. Sorry about that. I'll just rewritten what we had before. So area of the sector, I've substituted theta, 70 degrees. I'm going to do my r as well. So just squeeze it in here. Sorry, r is so times 18 squared. So substitute your values into that formula we had. And then just simplify and multiply. So then we're left with, if I cross off my zeros, so 7 over 36 of pi times 18 squared is 324. Sometimes it helps to break up your equation and do some parts step by step, just so you don't make a mistake entering it all into your calculator. The area of the sector, I'm left with 197.92033, and it goes on. And the question asks us to round it off to 2 decimal places. So the area of this sector is equal to 197 point, so 2 decimal places, my cutoff line's here. Before I get rid of everything else, let's check. Number after 2 is 0, so I'll just get rid of it. It's less than 5, so I'm left with 197.92 centimeters squared. Don't forget your units. Okay, so number 3 asks us to find the area of the shaded region to 1 decimal place. So have it go first. Okay, so when approaching questions like this, always work out first what is it that you have and what you're trying to do. So the area of the shaded region, if I just quickly shade it in, was the part around what looks like a square. And to double check, it is a square because if I extend these points, these lines here, sorry, my circle's not the best drawing, but look at the accurate one. That'll also be 6 centimeters, 6 centimeters, and 6 centimeters. So we know a square, its diagonal lines are equal. So if I just drew this square, if I took it out here, so that will be a diagonal line of 12, and as well over there, 12. And we know diagonal lines go from one corner to the other, just like a rhombus. So that might be useful, remembering that a square is also a rhombus. So we can also use that formula if we're given the diagonal lines of a square. So let's work out what we have. So we have a circle, so area of the circle, take away the square, will leave us with the shaded area. So the formula for a circle, we'll do that first. So area of a circle is equal to pi r squared. So area is equal to pi, r is 6, I can see that, so 6 squared. So area is equal to pi times 36, and to 1 decimal place I have 113.1 centimeters squared. So I found the area of the circle. Now I've got to find the area of the square to subtract it. Now you may have used Pythagoras for this, to find the length one of the lengths of the squares, the side lengths, that will work as well. But what I'm going to do, I think it's quicker to use the diagonal lines of my square. So the area of a square can be found, yes, using L times L. I don't have a side length here. It's not given to me, but I have the diagonal length. So I'm going to use the formula for a rhombus. So the area is equal to x times y divided by 2. We see that in a rhombus. So area is equal to, so in this case, the diagonal lines are the same. So it's like I have x times x. So I'm going to have 12 times 12 divided by 2. So area will be equal to, it gives me 72 centimeters squared. Okay, so now I've got my area for my circle and the area for my square. Final step is to subtract. So I'll just say shaded area. So therefore, shaded area is equal to 113.1 take away, so the bigger circle, take away the square, which is smaller. So my area will be equal to 41.1 centimeters squared. That's to one decimal place. Okay, question 4. It's more of an application problem, and it says the length of a rectangular lawn is 3 times its width. If the perimeter of the lawn is 56 meters, find its dimensions. So dimensions is referring to the length and width. So using this information, can you work out the length and width? Have a go first. Okay, so when approaching these kind of questions, break down the information. Here is the key information. We've got the length of a rectangular lawn is, so I'll just highlight that, is 3 times its width. So length is 3 times its width. Can you write that into an expression or an equation? Yes, we can. So length, so L for length is equal sign instead of is, 3 times its width. How do I write that? 3 times its width. So 3W. So I've worked out what L is. L is 3W. They've also told us in the question that the perimeter is 56 meters. So the other thing I can do is have P is equal to 56 meters. Okay, I'll double check. Is there anything else I can get from this information? No, just tell us now to find the dimensions. So now that I've gotten the information from the question and I've summed it up here, my next step is they're telling us I'm dealing with a rectangle, a piece of lawn that is a rectangular shape. And the area for a rectangle, oh sorry, we're not doing, we could use area, but let's use perimeter. Because, we can't use area because they've actually given us the perimeter here, sorry. So we have to use the perimeter of a rectangle, which is perimeter of a rectangle, write down the formula. It's 2L plus 2W. So we've got 2 lengths plus 2 widths. Okay, so L plus W plus W. Try and simplify it if you can, just to make it easier for yourself. So there's my formula that I'm working with. Now that I've got that, all we have to do is replace this information that we got from the question, replace that or substitute that into the formula. So I've got L is 3W, I've got an L here. So instead of L, I'm going to write 3W. And instead of my P, I'm going to write 56. So 56 is equal to 2 times L, I'll put it in brackets, which equals to 3W, plus 2W. Okay? I don't have information for W at this stage. Now you can see what's happened. The whole point of this is I can now solve this equation. I've gotten rid of my L and my P, and I've put values in there, and I'm left with only an unknown variable of W. See, I've got W here and W there, and nothing else. I can solve this now. So let's simplify first. So 56 is equal to 2 times 3W is 6W plus 2W. So 56 is equal to 6W plus 2W, they're like terms, so we get 8W. And then, if it helps, write 8W equals 56, just switch them over. And then divide by 8, W is equal to 7. And in this case, we're dealing with meters, so 7 meters. So what's that telling us? The width is 7 meters. So width is 7 meters. I found it. And the other one I have to find is the length. So, and I'm done. So how do I find the length? Well, here they tell us the length is 3W. Okay? So the width tripled. So if W is 7 meters, just put it into that formula here. So length is equal to 3 times W, which is 3 times 7. So length is equal to 21 meters. And I found my dimensions. The width is 7 meters. And my length is 21 meters. And I'm done. Okay, our next question says, if the length of a rectangle is one more unit than its width, and then doubled, write a rule for the area in terms of its width only. Okay, so it is a bit of a mouthful, but try and break down the question. And what it's asking us is, in our rule, in our formula, just to have W only. So sort of, it's basically what we did before. Before we eliminated the L and P in that formula and only had W. That's what it's asking us to do here. Okay, so break down the question. It says if the length of a rectangle, so I'll highlight the important part, length of a rectangle is one more unit than its width and then doubled. Okay, so for that bit of information there, write an expression or an equation using that information. Okay, so L for length, equal sign for is, so length is, and then we have one more unit than its width. So one more means plus 1, but then what? Then its width. So W first, plus 1, one more unit then its width, and then double. This is really important that we put brackets around the W plus 1 and then double that. Okay? So we have length is double its width plus 1, basically. But if you didn't have brackets, it would have been wrong. Okay, so that bit of information is summed up here, and we can see what's happening. It's telling me L is this part here, and I can see over here there is no L, only a W. So if I substitute it into my formula, I'll only have W. Okay, so write a rule for the area in terms of its width only. So we're dealing with a rectangle. So the area of a rectangle, we have a rectangle, got length and width. So this time we're dealing with area. So area is equal to length times the width. Okay, so our next step, just work out what we're dealing with. Okay, so I've got, in my formula, I've got L and W. And I've worked out that L is this part here. So L is this bit here. So I'll replace L over there with 2 bracket W plus 1. So using substitution, my area is going to be equal to 2 bracket W plus 1, because they told me that's what L is, times W, and I'm pretty much done. There's my rule, or my formula, and W is it, and it's in terms of width only. I've got W here, W there, nothing else. Now we can simplify this. So if a question says to expand or simplify, don't just stop here. So we've got times W here. So we end up with, what we end up with is, just combine the 2 and the W. They're both on the outside. So 2W bracket W plus 1. And that's simplified. I'm not going to go any further because it just said to write a rule, and I've got that here. Okay, and for our last question, it says calculate the volume of the following. Now have a look and see what we have. Have a go first, of course. We can see that we've got a cylinder, but it's half a cylinder. And we're working out the volume. So let's just recap what we do when it comes to volume. Okay, so when it comes to volume, we know the general formula is volume is equal to A times H. And we learned that A refers to the area of the cross section. So area of cross section, and H refers to the height, but we know it's not just height, it can mean height or length, or sometimes I say distance from one cross section to the other. Okay, so let's work out what the height is, because I can see it in the question. So height is, so cross section is what you see on one end, the same shape on one end and on the other. So I can see my half circle here, and there would be a half circle on this side here. So that's my cross section, the half circle or semicircle, and the space or distance or height or length, whatever you want to call it, in between this semicircle and the one at the back is, they're telling us it's 3.7 meters. So straight away my H is equal to 3.7 meters. It's given to me. But what I have to work out is, what is the area of my cross section? So in this case, what is the area of my half circle or semicircle? That's what I need to work out. So area of semicircle, I know a semicircle is a sector, it's half a circle. So I'm just going to say half of a full circle. What's the area of a full circle? Pi r squared. Okay? So that's a full circle, pi r squared. I've got half of that. So that's going to be equal to half of, right, times. Now r, be very careful, that 1 is my diameter, 1 meter. So r is going to be 0.5 meters. Always do that first. So pi times 0.5 squared. Okay? So the area of my semicircle, I'll just keep going and simplify this. Now the question didn't say to round it off to 1 or 2 decimal places, but I might round it off to 1 decimal place. And I'll try and do that at the end, just to have a more accurate answer. So what I mean is, I've got area, we're doing volume. Sorry, the area of the cross section is equal to, so I'll end up with pi times 0.5 squared is 0.25, and I'm dividing it by 2, or half of that. So there's the area of my cross section. I can round it off here to 1 decimal place, but I'm going to just put it all in my calculator at once. So that's the area of my cross section. So volume will be equal to this. So I'll just change it to V here to have some space. So V will be equal to area of the cross section times the height, which is 3.7 meters. We'll leave that till last, the meters. So put that all into your calculator at once if you can, and we end up with a volume of 1.45 meters, and don't forget to write cubed. That's a two decimal places. Or 1.5 meters cubed. Sorry, it's a bit hard to record when you got kids. So hopefully that has helped you with your studies, and keep practicing. Thank you.